Okay.
Cool. So, hello everybody. My name is Adarsh. I think a lot of people call me Alu. I usually introduce myself as Alu, so that's maybe a confusion. I'm going to talk about Dividat, the company I work for, and we use basically in production. So just to talk about how we use it, like how the code looks, what we're doing basically, and importantly. So first I'll start with just like a brief overview of the company, like what we basically do, so just so you get an idea of what the software is. Then talk about how we organize our code. I think something which is interesting is like the build system, where we build stuff. One thing interesting we do is we connect hardware to our web applications. And so I'll talk about how we do this. Some Elmish patterns, which I think are cool to use. And then one thing, I try to pack the design of our whole code into the presentation, but it seemed a bit too much and it was not so clean actually. So I extracted like a pattern which seems to be like what we're using, to create like components and subcomponents and stuff like that. And we can have a look at that. And then some like open challenges we're still working on and I'm going to be doing, which open for ideas. So what does Dividat do? Basically, we make LED people dance. And this looks a bit like this. So yeah, we have a hardware plate, which you can see down there. And on the screen, which is connected to the computer and the hardware, there's some stimulus which happens, some games which happen. So something moves or something happens, and then something, like for example this game, the red dot, if the red dot touches one of the white dots, you're supposed to make a step to the left, in this case, or to the front, or the right, or the back. And this is like a game-based training we do for elderly people. The lady here is not very elderly. And this is what we develop. So the games, what you see here on the screen, this is developed in Elm, and also a management interface we have. Maybe just some quick stats about Dividat, which is not very interesting. We are an ETI spin-off, but we're not an ETI spin-off from the computer science department. We are a spin-off from the movement science department to develop this cognitive motor training. So the architecture or the software we have is this product we call Play, or the software we call Play. This is the games. We have the manager, which is the management interface. You can like watch how the training is happening, who's training, like set settings and stuff like that. This is all connected to data backends, where the training data from the games are stored on the data backends. And then we have a hardware, which connects with the game software. And we'll talk a bit more about this connection here. So, how big is the project now? In total, it's, you can see here, it's 132 modules. So, medium size, I guess, or largish. Yeah. So, something I find interesting is how we organize the code. And what we use is that we have everything in one repository. So there basically are two software packages: the manager and Play. Maybe we can have a look at this. This is how the Play, so the game interface looks. You log in and select the person who's training. And then you start on the games. This is a very simple game. This is just a baseline test we use to get like basic reaction times. And then we have more complicated games which like cognitive functions, and then we can like see what was the difference.
This graphics based or?
This is SVG based. And this is something interesting, like the data which is stored. So you get these points and time and reaction times. This is then stored on the backends. So now we go to the manager. You can see it's simple. This was exactly this thing. This is stored on the backend. And we get this in the management interface. We have this data, and we can also see the previous trainings. There are not so many previous trainings here because I just re-analyzed the database. We can have a look at the live server. So there are people training and different games. up there. And you can see a whole list of people who are training. This person does not have any data, but yes. So this is basically what the software does.
Is that real people's data?
This is just text. This is like.
Okay.
I wouldn't show you the real data.
No, because I would look at the URL.
Yeah, this is just a testing. So both of these packages, like the manager and play, are in the same repository. Look at this here. I don't know if you can see this. So we all keep it in the same place. And we don't really only keep it in the same place, we just really keep it in the same code base. So how we compile this is we have two different files. One is play.js for the play software. And this just gets, gets styled first. It starts against the Elm application. And here's the only difference. This gets played. If you have a look at the manager one, this one just gets manager. And then manager main.elm is just the usual Elm program. Now, what the advantages of this is that we share libraries which both applications use. For example, access to the data backend is in the same tree. So you can just do it for Dividat and it's in the same thing. If you make changes, the both system compiles both of the applications at the same time. So if you change something and it changes it somewhere else, you'll see it. It's interesting, maybe like stuff like initial flags. This module, this JavaScript module, this reads from local storage a saved token. So if you're already logged in, it'll get that from here and use it as an initial flag to start the program. What else? So we have other things like web audio, which uses ports. Is everybody familiar with ports? Yeah. So this is a JavaScript module. So look at that. And this is basically, it starts like all the, this is what's called web audio API to just play sounds. This is used in the games. So, and it takes as argument, it takes the app, which is the Elm app, and then it simply loads or binds this port to the application. So it's very, the initial file is very clean and what else we have is the Chrome driver. This is what the hardware connection. I'll talk about this later. So what we use is Webpack. I mentioned this, and this is the Elm module plugin for this is Webpack Loader. But there were some problems with this, so we have a slightly modified version of this. One thing was that the way it checks for dependencies is not very efficient, and actually I ran out of file allocators on my Mac, so I need to optimize that a bit. And some other things, like if you have two starting points in the Webpack configuration, which we have manager and play, it messes up the temp files because it just deletes the temp file after something doesn't work. So we have to hack that a bit. What we also have is hot loader, so that like hot loads, all assets like all our style files and everything is compiled the same thing, and it's loaded like so here. It's just simply loaded in the JavaScript main file. Yes.
You did talk about Elm Webpack loader. Did you make a pull request or an issue for the
no, but it was
branch?
Not yet.
Okay.
There was a similar request regarding the checking for the dependencies.
Okay.
But basically, maybe we can talk about this just slightly more in detail. What Elm Webpack Loader does, it reads the source files, makes a graph, and traverses it, and tries to find everything by itself. Basically, what the compiler does, it does again. And it does not do it in a very efficient way. So what I do is I just read the Elm package.json file, take all the sources, and log that. So any file which matches this. So any Elm files which are in these directories are just considered to be dependencies.
Okay.
Yeah. So it's not perfect because there might be false positives. Yes, false positives. Files which are included which are not dependencies. but it's way more efficient to just run like that instead of
Okay.
that.
I think that Richard will be extremely interested in
But
learning about that.
there is a pull request for this, and the has also been
Oh, okay.
and it has not been resolved yet.
Okay.
So this is,
But yeah, if you would consider
yes, absolutely.
raising your voice there, it would be. I think it would be appreciated.
And the other thing is the temp file. If you have two mount points on that type of relation, it's nice. But I also get this.
I'm just asking because we are now trying to use Webpack at our code base.
Okay.
Thank you.
So for the organization build system, I think this is very interesting because this is, you use it all the time. Something maybe cool I can show you is maybe try to do something like something just wrong, which would break it. Let's hope it breaks it. Yeah, you see. So broken. Now this again. And reloads again. I should be seeing like a pop-up. I think because I have it on the thing, it does not show. But I also get like a notification if it fails to build it, like pops me up. Sure.
It was a pop-up down
Ah, okay. Right. You mean in the Atom, in the editor?
Yeah,
No, but there would be a system notification because this runs in a separate terminal,
Okay.
and it would like pop up a notification for something approved. Oops. This is the Freckle tab, and yeah, maybe let's go about and talk about this. Or first, maybe the hardware. Let's first go to the hardware. That's a bit shorter and easier to explain. So what we have is the M application, and we have our hardware we are developing, and these need to communicate. So one way to do this, and I think a lot of people do it, is use WebSockets. So they have a small application running on the computer, which is connected to the hardware, and offers just a WebSocket server. Then the web application just connects to local host to that WebSocket server and connects to the hardware. This is one possibility we also try, and actually use this for debugging because it's easier. But the problem with this is SSL certificates. So if the web application is running on a secure site, any connection it makes also needs to be a secure site. So localhost server needs to be a secure site. And then you have like all the trouble of installing the certificate if it's self-signed. You cannot give out real certificates. So that's a pain. What we did is we use Chrome. So Chrome has an API which allows you to connect with any kind of USB devices. In our case, we have serial devices, also networks. You can just connect any TCP socket, you can open TCP socket with the Chrome API, and in Chrome for Chrome apps. And then this Chrome app, you can connect with websites. That's just me way to do this. And this is exactly what we do. So let me show you how it looks, how we get this hardware signal in. Oops. This is one of the games. This was a simple game you just saw before. So the very simple game, it just shows the buttons. And what is interesting is here. Subscriptions. This is the interesting thing. This is where we get the hardware signal. So first thing is animation frames just for animations. We use keyboards. This is straightforward. And then we map it to engine. Engine is like our game engine, which does like hardware conversion and stuff like that. And it takes care of how to have the keyboard. And then we also have the driver. And the step that is the hardware we use. We also send to the engine. And this is very neat. This is actually very neat in M0.17. In 0.16, it was a bit more of a tricky matter to get subscriptions like this so nicely. So I'm very happy about this in 0.17. If we go then to driver, the ARM side, this is very simple. This is just the words. And you also see this is a string, so it does not decode the JSON yet. The JSON is decoded in the engine. And then if you go to the JavaScript side, it goes like this. So basically, here it connects to the Chrome runtime. And this is some key you need to allow to connect the application you have installed. This is applications to your Chrome app specifically. And then we simply add, here we go. We just link these things we send it output, and that's how we get the signals in from the hardware. I think this is pretty neat. The advantages, I mean, the disadvantages if you stuck with Chrome. The advantage is you can also use this on Chromebox devices, super lightweight things. You don't need any drivers which are running in operating system. It just runs on Chrome. We now use it for this one hardware we have. We're also using it for RFID readers. We're developing this. This is slightly more tricky. And the next development of our hardware uses TCP sockets, which we use the same strategy to do this. Some nice patterns and patterns, very Elnish patterns we use, or we happen to use a lot, is this thing called loadable. So if you want to load any kind of data from a data backend, you use this type. So it can be either init, it is nothing loaded yet, and then you send a message to load something, and it changes into loading. You set this to loading. Once the data is loaded, it's loaded, and it is an error, you have the error again. So this is a very nice way to handle loadable data. This is all inspired by somebody who did this before, but he did a bit more. Well, I didn't like the names he used, but so I did myself.
It's a nice blog post to read.
Yes. Maybe you can see it in. I'll look at this how it's in real code. This I'll show you in the software. This is maybe also interesting. We have this concept of different accounts, and depending on what kind of account you have different access rights. So this is just a simple account which has access to one organization. But if you go in as admin, the view changes slightly, and it detects that you are something else, you have more rights, and you can do more stuff. So here you see this organization. This is one concept we have, has this account. And this is what the code we're going to look at now. Accounts of lists. And here you see it. The small list, very simple. I just loads it and this. Initialize as init. Updates, also very simple. Just three basically load it, get accounts, plot the accounts, whatever happens, and then select accounts. Maybe what is also interesting is the view. So we just make a case on what state it is in. If it's initializing, you just slow the loading spinner. If it's loading, also a loading spinner. And if it's loaded, then you also have the object, right? So you can just use that in that instance.
One question.
Yes.
Why do you need distinct init and loading? Couldn't you just use loading?
Sometimes it's not clear if you loaded it yet. Like sometimes you need to press a button, and then it starts loading. For example, let me show you this. When we log in, to get the token from the authentication server, now it's an init.
No.
Okay? Only if these, no, it's so fast you don't even see it. If it does a request, it goes into loading, and then it goes into error. Now it's an error, right? So this is one thing.
That's something she talks about in blog posts, that a lot of applications have this problem that they don't show the states correctly. So sometimes you are in an old state and it's not in the init state, so it shows all state, like it shows that you have still notifications, but it didn't actually load the data. So it shows notifications, and as soon as you go there, it's loaded and it shows that you have no notifications, for example.
Maybe I'm missing something. In my app, I use just collapse because there's no distinction between the states, but
Yeah.
maybe you
Yeah.
have different cases.
Yeah.
But if you're both loaded and also loading additional information,
If you're loading and you're already loaded,
just add an extra entry.
yeah. Something I'm working on, but I'm not very happy yet with, is editable. So sometimes you have data which is editable, like for example, person, you have this fields like a name, surname, whatever. And this is, first of all, it's loadable. Once it's loaded, it's editable. And so I'm just thinking about something similar, but I'm not quite happy with it yet. And maybe I can tell you why I'm not happy with it yet. First of all, you need comments to explain what's happening. And some things you can also do is like if you're saving, or if it was an error, you can't go back. So you probably will also need an A here to have like the original value stored, just to go back or to have your edits, to not lose your edits, stuff like that. And there's some other cases like, yeah, this would also mean that in saving you would also have to store the original, or well, yeah, it's not quite clean yet. I'm not quite happy with it, but maybe we can talk about this later. So yeah, like this. Then maybe to the, I think, fractal pattern. So what I did today is I tried to think about how I could explain how we organize a code, and by showing you the code, but it seemed a bit like a mess. So what I tried to do is extract like the pattern we use to organize the pages and sub-pages and all this stuff. And I made a minimal example or a small minimal example of this. And basically it looks like this. Let me show you maybe the sub-page, so it's just empty. And then we go higher up so you see how it goes. This is it looks very standard down. It is standard down. So you have the model, you have the init. The difference in the start app, init does not give you the model and some command, it just gives you the model. Messages, context, mount. This is something special. And so this is loaded, this is run every time the page is loaded or mounted. And it has this very similar signature to update. We'll talk about the exact signature a bit later. Update, standard stuff, and view also standard stuff. So what we try to do is like we have all our pages for exactly this pattern. There are also not any more functions because I try to inline the functions to view, and you only use it in the view. I inline it in the function. So this is basically how all the things look from up.
So you inline all the functions with let in, and
yes.
Do you add type signatures for that, or?
Sometimes, if it is too complicated and I don't know, or it's not exactly clear what it's supposed to do, then I have signatures as common functions, basically.
It's interesting because we try to never use let in at loading.
Okay.
Or like, I would say like half of the engineers try to do that, but I'm only there for 2 months, so I can't say like in general.
Yeah.
But it's like we try to avoid it.
This is a pretty recent thing I started doing, trying to inline everything. And I think the reason is just top level, if you read it, it's very clean. It's just update and here, that's it. If you need something from a view somewhere else, then yes, but then it's clear it should be like reusable. Then it should go somewhere.
The thing I don't like about let in is because it reverses the order of how you read your code. So you start at the bottom with the in, and you have to always go up. So you are not going top down with more specific.
Is that something you're considering? Because I think Haskell has something like where it's flipped.
Yeah, I'm not sure if it's considered for a future version, but it's, I talked with Noah and Hardy about it, and I don't know if Evan knows already that people are talking about this, but I don't know. So I'm really new. I don't want to say something false.
Yeah, but what's the trouble with only exposing those, and then you can have private functions too?
True. It's absolutely. It's not about
so just a preference.
It's not about what's exposed. Of course, you should do this. Like you should always only expose what you're exposing. Yeah. It's just about like how it looks, how I navigate this stuff. It's just a personal preference. Let's go one up.
Can I ask one more
yes,
question?
Sure.
Like, if you have inline functions, then sometimes you can get more variables basically from the closure of the outer function. Do you use that, or do you keep passing in all the arguments?
No, I do actually use this. I'm not looking for an example of this. And I like this a lot because if you add the arguments in there, it seems redundant because it's always going to be the same thing.
Mm-hmm.
Right? So it's always going to be the same thing. It's anyway, depending on whatever is the arguments for the model, maybe. Then I don't see any reason why I would want those.
I think the problem with that is that you hide stuff that you don't see from like a signature, that it uses the model. So you do it like not explicitly that you use the model, and I think that's the only reason why I would not use let in and the thing with the order.
That is good argument.
But if you use type signatures in the let in, then I think then it can be okay. Or it obviously works for you, so it's okay.
Yeah. Let me see, maybe I can find an example of this. There you go. Well, no, this does not use anything. This uses accounts. So this is the same thing you saw before, the list of accounts. It gets the accounts, and then there's a row for every account.
That's a good example for something where I don't like the let-in, because like it's already indented a lot
Yeah.
because of the case, and then you have the let-in, and on the bottom in the in you don't know in which case you were.
Yeah.
So you have to always go up to read it. But that's like maybe personal preference.
Yeah.
And
Maybe one motivation for this is just reading this, you know what's happening.
yeah, but
Right.
you have so much noise before that,
Yeah.
before you see what that case should look like.
Yeah.
So that's the thing I don't like about it.
Yeah.
But
These people, you guys as well, these people, you're describing it, try to work in this way. Because I can see the point, if you're having a lot of functions in this file, and you probably have a lot of small functions, then it might be hard to see which are the important ones. So they have some kind of way of organizing a file that comes to one to say, this is the main thing, and below there is just...
yeah, I think it's like that's how you read. Not like code is at the top, it's more general, and then you come to more specific stuff. And if it gets too long, you just start to refactor it and pull it out to another file.
Apart from JavaScript, you mostly can do that because you have to...
Yeah, you probably run into a lot of errors if you start ripping out stuff. But we do that a lot. If the file gets bigger and bigger and bigger, and then you start ripping out half of the code, and you don't run the site for an hour or something, and it compiles and it works.
Mm.
So I think that's something nice, that you don't have to think about how I structure everything before, like you have to do in JavaScript, but you can just start and keep on working, and if you see it gets too messy, you can refactor it easily.
Yeah, refactoring is super easy. Almost too easy.
Sometimes you can't believe that it works. Wow.
Yeah.
I don't know why. So
I think we were here. Yeah, this is just the empty base case. If we go one level up, maybe I should show you what this ends up looking like, right? Let's start. It's already started. And this is it. So there's a page A and there's a page B. You go to page A like this, and you also see the URL. Go to page B. It adds this one, and one is like an argument this page B takes. So go to page 3, 4, and you say it's still page B, but some value. So the model, this is the model of page B, is set to 4, in this case it's set to 3. If you go back to 1, page A it's still page A, but B is still set to 3. So this sets it in the model. Okay. And this is one level high. So the only difference is you have a page which tells you where you are, and then you have the models of all the subpages in there as well. Let's have a look at what the page is. Oops. It's basically this way. The page is basically page A or page B, and page B takes a string as the argument. That's it. Initialize also the same thing. And you use these fractal things happening. Exactly that things happen. Use the init of the subpage to initialize it. Messages, this is also something you use, like map whatever message is to the subpage. Subscription, I will not use this here. And then the mount thing is a bit more interesting. So the mount now takes an argument page. Maybe I should first show you how page B looks. The mount, it has a string, and this, what I usually do is the mount, the signature of the mount always has the arguments of the page before it. So if the page here takes an int, or a string and an int, then this would be string, and then right? So this mount function just sort of this page is loaded now to see. And then the signature is very similar to the update function. In the sense, you get a model, and you get a model and it's on. Going back. Because fractal, like the top one is the top thing, it also gets the page as well. So this is only for one topmost page you have. It just gets the whole page. There's no arguments, it gets the whole page. And it's just how they do. And it gets page A, and if A happens to load to A, it mounts it to there. If it's B, it mounts B. Update also very straightforward, I guess. So if it's page A message, you do whatever page A update says you should do. If it's page B message, you do whatever page B is. And then in the view, like to decide on which page you are, this is more like login stuff. Here is an interesting thing. So the content of your page is basically just the switch statement on which page you are. And this is how I saw how like most of the stuff the users is done. And it does like maybe it's somewhere where it's working. And you can use this kind of composedly. So we have here, you can select an account and view like data about this account. And you have the same view if you go to my accounts. It's exactly the same for that. Also the URL. Although this does not have an URL. Yeah. But it's basically the same thing. Right? You can mount stuff in different places and switch them around.
So we both have init and mount?
Yes.
Okay.
The reason for init is because if you don't mount it, you still need to have something in it of the right type.
Right, but could you use mount? Could you make init do what mount does? Or is there a significant?
There might be significant stuff. Like sometimes if you mount a page, you want to get data. And you would not want to get data when you initialize the application.
Well, you can run a command. Yeah.
Right? So
no, but like your init could also return command, like a couple,
yes.
a pair of
Yes.
model and command.
Yes. This exists also in the code. And I think this is like the standard way startup does, because the type signature of init and startup is model to model CMD command, right?
Yeah, in your top level.
Yes. So what I ended up doing is a lot of firsts of the init, which I did not like very much, because it seemed like, I don't know, throwing away stuff, which might be important, but it's...
I think something to consider also is that tutorials and stuff about architecture have these
Yes.
types,
Yeah.
type signatures, but if you don't need site or like effects or commands, you just remove it from the signature and it's fine.
Yeah.
Your code ends up not looking quite the same everywhere.
Yeah.
But sometimes you don't even need a model, so you just need
Yeah. Yeah, so that's the thing. Maybe you can have a look at how it looks a bit more messy in real code.
When apps get very large, I mean, what happens to it? Does that get bigger and bigger and bigger and bigger? So like, if you have 100 windows, I'm learning on at the moment, but the app that we developed has about 700 windows.
Yeah.
And it's huge.
Yes.
And it's not a lot of people, but I can imagine 700 of those things in there. I mean, make for a very big file.
Sure, yeah.
Or does everything expand that way, or do you have to then structure application to have main topics, and then each main topic basically has a tree structure underneath it, and then that would then instantiate these sub-pages in that sense? Would you have to structure an app that way to prevent something from, to prevent that class from becoming endless?
That's what we do. I mean, it's not nearly the magnitude of size, but yeah, it's all hierarchical, right?
Okay.
So you have like persons, and then there's persons, which is a list of persons. And you have person underneath that, and then underneath person, is that what it is? So it's like, this is the persons. We can also have a look at the URL, because the URL exactly corresponds to this because of the way it's done. So person and persons, then you select that, and then you see the ID as you add to the URL. So you're in one level lower down. And then you're also in data, it automatically sends you the data. So you're on the data page. And if you go to management, it switches you to management. So you do it hierarchically.
If I can jump in, sorry. So we have a big application, and so one thing I think about when I'm writing Elm and about the architecture of an application is that we are all used to build like big JavaScript applications where you have to consider the architecture of like the end huge application before you start writing stuff, because you may run into problems if you have to use a router after you like created a bunch of code. And the nice thing about Elm is that you don't have to think about everything beforehand. You can just start, and if you see a problem, you solve it. So, and if the application gets bigger, you are more experienced, and you can easily solve these challenges. So that's something I think that you always have to have in mind. That it's a huge problem at the Elm community, I think, at the moment, that a lot of people who are new to Elm want to know how does a huge application look like. But you don't have to think about that when you're starting. So you don't have to think about every possibility that how should my architecture look like. You can just start, and if you see that something gets messy, you just rip it out and refactor stuff. And if you see, okay, now the application could be a success, I need a router or something, then you start using a router. Or yeah, and I think that's the way you should go on building a Elm application. You obviously did it. You have like strict architecture beforehand. That's a good thing if you feel comfortable with that. But maybe if in a half a year you will change everything, and it's no problem because it's really easy to refactor stuff because of the type safety you have. So I don't think that. I think you should just start writing Elm and see where it gets you, and after time you are more experienced and you will solve all the challenges you think you will have them.
Absolutely, and I think also just like the way what I'm showing you now, it's not all the code looks like this. That's why I have trouble like finding like a pattern of this. And I think this is just like my momentary way of doing it. When I write the new page, I will do it like this. But also like what I also do like is like having the other pages in a similar way, because if I want to change something on a page, it should be somehow familiar to me, right? So then I go back and change it to this. So refactoring is easy. And yeah. And maybe we'll stick to the games. Like the games are completely different. The way the games are loaded, they are like almost standalone applications that just get loaded in. So those are completely different things, and they also run in completely different ways. Some interesting things we were thinking about is like graphing. So you saw some of the data before to present this nicely. Have some graphic stuff. Automatically generate reports, which would also be nice to be exportable as PDF or as raw data, as JSON or maybe as Excel stuff. This is what we're working on. Another thing is internationalization. That sounds called YAD9. Hardware. We're developing slightly more sophisticated hardware, which is much more sensor data. You get much more sensor data from it. How to handle this in the engines and the games. That's going to come. What we're also working with is we're starting a project with the ZWK, the arts school here, to develop games. And they were using Unity game engine. And we're going to have to see how to like interface this with our stuff. So that's one of the big things. And then testing, we don't really have any testing except for the compiler compiles. And we trust the compiler slightly too much. It's working out nice. We had like small things like the delete command was sort of the cancel command, stuff like that. But and the compiler said it was okay first. Yes, that's one thing. I'm also looking forward to hear how it works. And maybe also data analytics stuff, that also might be something which might be able to do server side vending. Yeah. Cool. Thank you very much. Questions or any more questions?
Have you actually had a look at any? Do you have any ideas for solutions for translation of the page?
So actually, interestingly, we talked about this at the last meetup, or we talked about this. There is a blog post. This guy, I probably won't be able to remember it.
Brian. I think
It's
that.
I saw it somewhere.
What about using just the type system to?
That's the idea. Yes.
So it's just one big union type which contains every key.
Yeah, that's the other thing which is not to mention. Right? This one.
Yeah. Right.
Right?
Oh, this one.
I think it's this one.
I think I've got one.
Okay. So what he does here, I'm not quite like this is one thing which already exists. Yeah. So using union type. But it's not quite worked out yet. I don't think anything more has happened since this blog post in March. Yes, so no real ideas. I mean, that's what's also important is tooling, right? Because people need to translate this, and there should be tools which should automatically or we need to develop tools which should automatically create something which we can use in the application.
Because it's fine if you're writing all the translations yourself, but the translator is not going to edit your own code to get that records.
Exactly. Yes. So, no real ideas. But there's some other people also doing this. So. No questions? Or? Cool.
So let's have a break.